So now we're going to talk about graphing polynomials. We discussed what a polynomial was in the last video. We have one extra rule here that is new to us, but after that, we're going to be synthesizing, pulling all of this information we've been talking about together so that we can create a polynomial. So the first thing we want to know is if we know the degree n, then we know the function has at most n real zeros and at most n minus 1 turning points. So that means if it's quadratic, x squared, it's going to have at most 2 zeros and at most n minus 1, 2 minus 1 is 1 turning point. And quadratic functions, things that are x squared, are always going to be shaped like a parabola. So it could have 2 zeros, could have less than 2 zeros, just 1. It could have no real zeros, be completely above or below. So something quadratic can have at most 2 zeros, and at most, you'll notice they all have 1 turning point. So there's always going to be one less possible turning point. All right, so if we think about graphing a polynomial by hand, we're going to talk about end behavior and shape using the leading term test. We're going to find zeros and x-intercepts considering multiplicity and behavior, cross or tangent, as well as identify a y-intercept, and then as need be, we can make a table of values to find additional points. So the end behavior. And we can do these steps in any order. I'm just going to run through them the way they are here. So my end behavior comes from the leading term. Because the degree is odd, we know we're going to have opposite ends. The degree is 3, which is an odd value, so we're going to have opposite direction ends. And because it is a negative leading coefficient, LC, we know that it's going to fall from left to right. So my general end behavior, my graph has this shape. Whatever I draw, I'm going to start high up here on the left, and I'm going to end low on the bottom. I don't know what's happening in the middle. All right? So to give us a little bit more information, we're going to find those zeros, the x-intercepts. And in order to do that, we set our function equal to 0. This is factorable. I can factor out negative x squared, which leaves me with x plus 2. So I get 2 values for my zeros. I have x equals 0, and x equals 0 has a multiplicity that is even. So we know we're going to be tangent at 0, 0. And then my other factor, I get x equals negative 2, which has a 1. So multiplicity of 1. That's going to be odd multiplicity, which means we're going to cross at negative 2, 0. So I need to plot these points on my graph. I'm just going to give myself a little space so it's not all up on top of each other. So I have 1, 0 at negative 2. And 1, 0 at the origin, 0, 0. So we have our zeros, we have our end behavior, we know the behavior of the zeros in relation to the x-axis. Finding the y-intercept, so my y-intercept is going to come from letting x be 0. F of 0 is negative 0 cubed minus 2 times 0 squared gives me 0. So my y-intercept is 0, 0. And whenever we have an x-intercept of 0, 0, we're also going to have a y-intercept of 0, 0. And if I wanted, I could come over here and make a table of values, plug numbers in. Like I could plug in for x and get out an f of x. If I plugged in 1, I would get out -1 minus 2, -3. And we can make these, or this, list of points all day. But we don't need all of that, and I'm just going to go ahead and start graphing it here. So I'm going to start high on the left, and we're going to travel. We draw our graph from left to right. So I'm going to travel down towards x equals -2. And I need to know what happens when I get to x equals -2. Am I going to touch it and bounce off, or am I going to cross? And at x equals -2, my graph is going to cross. So I've drawn it crossing. So I only have one other point on my graph, and I have to turn around at some point to get there. I want to head over towards my origin, 0, 0. So I have to turn around. What's going to happen when I get to my origin, 0, 0? So if we look, I wrote that it's tangent, which means I'm going to touch and bounce off. And so our graph has some sort of shape like this. So the one question I get here, and we can't solve this until we get to calculus, is how do I know where to turn around? Well, without our graphing calculator, we can't determine that max or min without our calculator. Okay, so use your graphing calculator to help you. And in calculus, we talk about derivatives and setting the first derivative equal to 0 in order to solve.